Hey guys. Welcome to the Ninja Monkeys Tutorials channel.
Hi, nice to see you again.
In our last video we talked about functions in general. In this video we want to talk to you about the use of references to structured data types as return values of functions.
During the research for our last video, we came across a paragraph in the Beckhoff Infosys that explains how to get access to a single element of a structured return type during a method, function, or property call. Beckhoff suggests to define the return type as reference to the structured data type. Because a single element of the return structured data type can be accessed directly. The background of this suggestions is that TwinCAT has to do less copies, because you use a reference to the structured data type. If you really need the single element once in the program, it is okay to use a reference.
But in our opinion this is bad style. Because it's not a reliable solution and can get dangerous. If you want to use a certain element more than once in the program, you should write an extra function for this use.
In this video we will try out what is described in the Infosys article and compare it to other ways that also can give access to single elements of a structured return type. We have combined the different options for you in a TwinCAT project.
Follow the link in the description to download the project file.
Before we explain the TwinCAT project, we would like to tell you what it is about.
We are currently developing a wonderful new fruit in our factory. We managed to cross a banana with a pineapple and invented the Pinana. Now we have developed a system that combines your favorite type of banana with your favorite type of pineapple, and in the end you get a Pinana made from these two types. Pinana combines the best of two fruits.
Let's have a look at the TwinCAT project now. In here we have the main. Main comes with 6 methods. As we mentioned in the video about programs, a program often works together with methods. We will talk about methods in detail when we explain function blocks to you. For now, you only need to know, a method contains a sequence of statements. In contrast to a function, it is not an independent POU, but has to be assigned to a function block or a program. The methods in our project are used either to mess around with the return values of the functions or to show which functions can be used without risks. One of the methods is used to skip these methods. We also declared references in the main. One to the Pinana from stack, one to the one from the GVL, and one to our new Pinana. Let's look what else we have in the project.
We have one function that calculates the curve of a Pinana, the other ones generate Pinanas. For generating the Pinanas we have prepared some structured data types and a global variable list. In a banana folder, you will find the banana type enumeration. This enumeration represents the banana varieties from which the Pinana are to be produced. 15 banana types can be mapped, namely from 16 #01 to 16 #0f. If you extend the type, make sure that only the least significant nibble is used. In the pineapple folder, you will find the pineapple type enum. As you may guess, here you find the pineapple varieties. So that everything remains unique, the pineapple variety is given the second nibble from 16 #10 to 16 #f0. If you want to extend the type, make sure that only the second nibble is used. The program generates the Pinana type by adding the pineapple type and the banana type.
In the folder types, you will find the Pinana type enumeration. This enumeration represents the Pinana types. The type of Pinana is determined by the simple formula, Pinana type equals pineapple type plus banana type. In the same folder you also find a structure called Pinana. This type struct contains the properties of a Pinana. Its members are a pointer to itself for the destruction of dynamically created Pinanas, called me. A member called Pinana type, which gives us the type of the Pinana. One that is declared as string, called variety for the name of the Pinana variety. The last one is of type L real and shows us the curvature of the Pinana. Of course, in radians. In the GVLs folder, we prepared a lookup table for Pinanas. We will have some fun with the table as well. The table is not a constant because the function GetAPinanaFromGlobal has a reference to Pinana as return value. And a reference requires write access. Let's begin. First we will explain the CalcualtePinanaCurvarture function. This function returns the curvature of a Pinana type. As we mentioned in the beginning, it's better to write an extra function if you need a return value of a function more than once in your program. This function is an example for this. The function always calculates the curvature of a Pinana. It gets a Pinana type as input, which is used as seed in the function block tc2system.drand. As the function block is on the stack, tc2system.drand should return the same value for each Pinana type. We instantiate it new every time, but it always gets the same seed. After we use the function block, we calculate the curve. The curvature of the Pinana is not specified in degrees but in radians. This function is used in the other functions we have in the program. In the other functions, the return value of CalcualtePinanaCurvarture is assigned to the curve member of the Pinana structure. We will start with a function that works like the example that is described in the infosys, to show you how dangerous working like this is. We activate the configuration and log in. In the main program we set skipMessWithStack to false. The method that is activated now messes around with the reference return value of the GetAPinanaFromStack function. This function returns a reference to a Pinana. The Pinana is created by a pineapple type and a banana type. And the reference points to a Pinana on the stack memory. In the implementation part we first validate the parameters, therefore we use a return instruction. After this we initialize the stack Pinana. Now let's go back to the method. In here we want to show you that working with a function like GetAPinanaFromStack is dangerous. Sooner or later, you will no longer get any usable values with this method and the return value of our function. Because the reference is pointing somewhere in the stack memory without us knowing exactly where. We will also show how quickly the stack memory can be overwritten and that this is dangerous. We assign GetAPinanaFromStack to the Pinana variable. As inputs the function gets pineapple type queen and banana type red banana. We assign Pinana.variety to the name variable and get red queen. In the next line we accept lady queen as name. It worked. Our result is lady queen. Next we create a valid reference but it points to the stack. We expect red queen but some weird name shows up. In the following lines of the method, you can overwrite the stack memory, if you want. We tested the program on different computers. In some cases it failed on the first run and we were referencing random addresses in the stack, like you saw it before. In other cases we had to run it a few times until it failed. If this happens to you in a real PLC project and not in our safe Pinana environment, your reference may point somewhere in the stack and overwrite things. So don't do it.
Now we set skipMessWithGlobal to false, to run the method, messWithGlobalPinanas. In this method we will mess around with the reference return value of the function GetPinanaFromGlobal. This function returns a reference to a Pinana. The reference is created by a pineapple type and a banana type. The reference points to a Pinana of the global lookup table Pinana prototypes.pinanas. We set a few breakpoints to track what happens when the method is executed. At first, everything works fine. The name variable shows us the expected name as string. Next we use the reference global Pinana. We check if it's valid. Again we use the name variable, and both values get us the expected result. In the next line, we overwrite the global variable. GlobalPinana.variety equals gold kiwi. In the next line, we expect red queen as result, but we get gold kiwi because we overwrote the global variable before. Something like this can happen quickly and is then difficult to find. We strongly advise against using a function in this way. Now we overwrite the global variable again with the old value, so that you can use the method again and again.
The next function we prepared for you is the GetANewPinana function. This function is also an example that shows how dangerous a reference to a return value can get. We activate the messwithnewpinanas method. The GetANewPinana function dynamically allocates memory and thus creates a new Pinana from a pineapple type and a banana type. The pointer pinana.me specifies the address of the new Pinana to free it again later. The Pinana allocates the memory as a byte, as Pinanas do not have the Enable Dynamic Creation attribute. It returns a reference to the new Pinana. In the declaration part we first validate the parameters. Next we allocate the memory for the new Pinana. And initialize the new Pinana. Let's switch back to the method and set some breakpoints to see what will happen. At first everything is fine. Now we clean up. Void equals newpinana.me. Delete, void. We normally should delete the reference again. With the line we commented out. But we don't do it, because that is not the point here. Now we use the function again. As name we get Lady Queen. And clean up again. And now we get a memory leak because we are not able to clean the memory anymore. This is because we just fetched the variety. And like this we have no access to the pointer that could delete the Pinana. Let's have a look at the error list. In there we find error messages that say, PLC instance did not free dynamically allocated memory at address, followed by different addresses of size 104.
Oi, a lot of errors. After we showed you how to do it not, we will give you two examples that show you how to use structured data types as return value without getting in trouble. The first function we created for you is the GetAPinana function. Its return value is the Pinana structure. No reference to the structure, and that's why it is save. It returns a Pinana from a pineapple type and a banana type. We activate the withCommonReturn method. It shows that with a common return, we can't do anything wrong. We assign the GetAPinana function to the Pinana variable. We assign a pineapple and a banana type to the function inputs. In the function the Pinana is initialized. It is returned to our method and we get the correct name, Red Queen. If we assign .none to the inputs of the function, no Pinana is initialized, because of the return instruction we implemented for this case. No name for us in our method. Wow, that just worked fine.
The next function we prepared is the IsSetPinanaCallByRef function. This function sets the content of a Pinana by a pineapple type and a banana type. It returns true if it was successful and false if it can't determine a Pinana of type pineapple and banana. The function clears the old Pinana content in every case. At the beginning of the function we set everything to null, for this we use the memset function. After this we validate the parameters. If pineapple or banana has none as value, the return instruction is executed. If we get valid parameters the new Pinana content is set. And the return value is set to true. The method withCallByRef works with the IsSetPinanaCallByRef function and shows that a call by reference is safe. And as you can see, we get the right result. The addresses of Pinana address and me address are equal. This function is really safe. You can't mess it up, even if you try to. To prove it, we added this little paragraph. It is not compilable.
Now that we've looked at the project, have fun with it. You have a couple of flags to control the data flow and mess around with the return values of the functions. As mentioned in the introduction, you can download the entire project if you follow the link in the description. We hope that our examples have shown you that it is dangerous to declare return values in the way recommended in the Infosys. Don't do it. You can't control them. Enjoy your day.
Watch our other videos and subscribe to our channel for not missing new content. If you want to know where we work, visit our LinkedIn profile or our company website. You can also find the links in our video description. Bye.
Bye-bye.